All right, we're back for day 22 of Advent of Code. Here we go. Okay, input is a bunch of numbers. Some of the 2000 secret number, they generate some secret numbers. Okay, they do some math. Some math on the numbers. Great, this is going to be basically a cryptography day, I think. So let me make sure that there's not two segments. There's not two segments. Cool. The next 10 secret numbers, yeah, so just implement some algorithm. 64, mix this result into the secret number. Finally, prune. Calculate the result dividing by 32. Mix. To mix, oh, okay. To mix, you XOR the two numbers, then it becomes the result. Okay, mix is XOR. To prune, do a modulus operation. Okay. Z will be the next secret number. Multiply, okay, mix this into the secret number. N times 64. Divide by 32. Mix this into the secret number. And then prune it. To prune it, okay. The result of multiplying the secret number by 2048, then mix. Finally prune. Okay, that's a step. I think that's a step. Cool. I need 0. That's important. Let's put that up here. Didn't need to put it up there. Probably shouldn't have. Next secret number in the sequence. Okay. Creation of 2,000 new secret numbers. Sum of the 2,000th secret number generated. Okay. Oh, come on. Oh, it should have been Z, not N. Why is this taking so long? Okay, there's a number. Oh no, did I have an off by 1 here? 2,000 secret numbers? Okay, well, for now, let's just try step of 123. That is not right. Fun. Given value mixing. Mix this result into the secret number. Oh, should we have been doing this with Z the whole time? This is like a little unclear to me. Mix this result into, yeah, okay, whoopsies. I think we should have done this. And then let's call step of 123. Is the right number? That's the right number. Okay, cool. We still locked out. 6 seconds. 3 seconds. Still not the right answer. Shoot. Now I might have an off by 1. Okay, well, doing it the second time did not work. So that's not fun. Evolves into the next secret number. Derived from the previous. Why am I not understanding the operation that's happening here? Is there more detail somewhere? 4 different secret. Let's try sample put. I should have done that. That's not the right answer. Oh, wait, sorry. We had a failing example. The step here did not work. Z, we're not using N anymore, right? No, we're not. We should be getting this. Times 64, mix. Then prune. Prune. Result of that operation. Okay, that's that. then divide by 32. How did I get the first one in the sequence but not the next one? Is the modulus step weird? I had the correct modulus, I think. Yeah. Oh, there's 3 prunes. That's not good. Oh, no. Okay, that was the problem, I think. I think this is my answer. No. Oh, that's the sample input. Oh, crap. Shoot. I might have hit the 5-minute lockout. That would really suck. 45 seconds, okay. I bet leaderboard is full, though. Leaderboard's full. Leaderboard's been full for minutes. Okay, so I'm not too worried about that then. Part 2 is maybe going to be full. Let me predict part 2 while I keep spamming this every few seconds. Part 2, so it's about some auction. Wait, we might have to do this many more steps. Is that the idea? We can cache this, maybe. I bet we need to cache it because we're going to do it many, many times. That's my guess. Rank 619? What is it now? Nope, it's not related to that. Something different. It's about the auction that's happening. Prices are just the 1's digit of their secret numbers. Okay, it's their first prices. Number of bananas. Only knows how to decide when to sell. Changes in price. First 10 secret numbers, prices, and the changes. Okay. The highest price would be 6. You can give the monkey instructions to see some number of price changes. Okay. Single sequence of 4 price changes. Can't change between buyers. Got it. Determine which sequence of price changes cause you to get the most bananas overall. Well, the most you can get from 1 is going to be... can this not produce odd numbers? We should try that real quick. Let's do... I just need to understand what's going on before I'm confident. Let's start it somewhere else. It seems pretty uniform. Okay. Cool. The best sequence to tell the monkeys that we're looking for. Okay, we could probably do brute force. There's 4 price changes that we care about. That it's technically 20 to the 4 because prices can change by a lot. If they never see the price change, I assume you just get nothing. Never hears and never sells. Okay, cool. Okay, this is probably brute forceable. We should just do that. Yeah, so let's do... how much we win from a given number if this is our sequence. So first, let's do changes. Step last, and then changes and next minus last. Yep, next minus last equals next. If changes is equal to seek, then what do we win? We win, so minus 102 would win us 6. So then we're going to return the equals next. We win next. Otherwise, we win 0 if we never see the sequence. And I think that's it. Oh, whoops, we need to do, we can only hold 4. we do this. Append to the end. Yep. This works. Okay. Yeah, the caching thing was kind of silly anyways. There's no way that would... Oh, I'm realizing now that brute forcing this is not going to be so easy because of the step is really slow. I'm regenerating all of this sequence every time. I could generate a bunch of sequences. How many monkeys are there? 2,000. That's kind of a lot. I should generate the sequences though, I think. I think that's just like regardless. One bit of pruning is we're probably not going to have our thing end in like a negative number. So maybe I could like cheese a little bit there, but it's not a big deal. Okay, so changes that append. Cool. And then finally, yeah, so I think this is the right length. And then, okay. And then for the win, what we're going to do is we're actually going to go through the, if I to I plus 4, I'm not sure if 3 or 4 is the right, but I'm not going to worry about it. Erring inside of cautious. Then we win sequence of I plus 3. 0 is the change from 0 to 1. So I think we win this. But let's check this. This is easy enough to check. Okay, we don't need this anymore. Changes. We really don't want this anymore. Yeah, I think this looks good. The thing I would like to test, I'm letting this run for now, is, okay, we have a terminal now. Win 123, shoot, gotta generate the sequences. Wish I put this in a function, crap. That's fine. 123. No. It's so annoying. Fine. I'll put in a function. I'm wasting so much time here. I should just no. Gotta write the brute force. How do people finish so fast? I guess 12 minutes is not that fast. Oh, I guess it just filled. I realized that probably time has already been reached anyways. Okay, well now I can take a bit of a chill pill. I still wish I put this in a function to generate the data for a given number. Seek changes. Okay. Seems wrong. What is this? N changes. Seek. Why is it so long? I feel like it shouldn't be that long, right? I did 20. Oh, right. Okay, I realized the problem. Oh no, I didn't mean to rerun that. Okay, that's fine. It doesn't actually take that long. Okay, 123 0 first 20 elements. Does that match? It does match. And then I'm just going to try and wipe this off the screen to make things. Okay, cool. How much do we win with Z1, Z2? And our target is -1, -1, 0, 2. No, that's not great. Z2 is. Oh, I forgot the mod 10 bit. Okay, that's stupid. Technically, I could mod 10 here, I think. I feel like my key manipulation has been pretty poor lately. Not really sure about that. These numbers do not look right because I could not have put the 10 there. That was a mistake. I completely forgot that this is important. Okay, at long last. Well, now I have 300, I think. Good thing I debugged that early, I guess. Okay, that. These look -3, 6, -1, -1, 0, 2. Okay, cool. And how much do we win if we have Z1, Z2, and we're looking for this? Then we win this much, which is a mistake. We should win 6. Okay. Okay, now let's brute force this. There's no way that it ends in a negative. Like, it is theoretically possible, but I just don't believe it. The input would have to be incredibly adversarial for that to be the case. What we want is the most bananas. Best and win for a seek change in data. Changes D1, D2, D3, D4. Max of best score. And then just so we can see how our progress is doing, get the PyPy going. I bet it's really slow. The question is how slow? Today is 22. Maybe a little bit too slow. It's taking that long to check. Oh, it's sorry. It's checking all of these. Maybe we should. There must be something significantly smarter. You could sort of guess that every monkey is going to actually win something and only try the 4 subsets from one of these data points. So let's try that. Yeah, so let's just do 4. Okay, how many? I think this actually was correct. And we're just going to check. It's just going to be data of data of 0 of 1 from I to I plus 4. This is going to be our set of changes to look for. And then we'll just try this. And this is target. It's technically possible that we don't. Yeah, so let's actually do the following. We'll check the first 10 monkeys, and we'll sort of just see how that goes. And we'll keep updating best along the way. That should be good. Oh, PyPy finally hit -8, but too bad, I'm killing it. Oh, I wanted to print something. It's so slow. Is there some observation we can make about the type of changes? I feel like it must be missing something big. I feel like these times are too, I don't know why I refreshed. I feel like these times are a little too fast for, okay, well, there definitely are GPTs on here. Just skimming the names. This is just really, really slow. There's got to be something clever here. Okay, well that's what I got the first iteration. I guess I could try and submit this. This feels a little low. How many monkeys were there on average? Or how many monkeys were there in total? There's no reason for this to... Wait, this is just like a ridiculous answer, right? I'm averaging less than 1 banana per monkey. I don't think that's right. Something fishy is going on here. Oh, I bet you get a lot of zeros. Because there are a lot of sequences that result in nothing. Okay, it's not changing, so let's just try and submit it. Nope. Maybe there's few enough things that we can store them in like a lookup table. Ooh, let's try that. Yeah, okay. So, yeah, because we keep going back through this, I think. So maybe what we'll do, rather than this whole thing, what we'll do is we will do so for every monkey, oh, what do you know? Beat it by 1. For every monkey, we will do scores of changes I to I plus 4. We'll turn this into a tuple, so it can be hashable, and then just add seek of I plus 4, 10. And then I think we just want the value, the max of the values. I don't know how long this will take. 2, 4, 7, 6. Okay. Well, that's not great. Now it's doing this stupid thing again. Why is that wrong? Let's give this a sample input a try. I like how they change the sample input between questions. Or between parts 1 and 2. Ooh, it was so fast. Because there's no monkeys. Best is not defined. 30 is what it thinks the best is. Oh, it's only the first one. Okay. Yeah, so it's only the first time that this appears, the sequence appears. I was going to call it seek, but I really shouldn't do that. If Z not in scene. 23. Okay, cool. Okay, rank 553. Oof, not a great day. That is for sure. I feel like this was not that hard to think of, but I just struggled a while to actually come up with the approach, which certainly makes me not so happy with how I did. Yeah, around like 600 for both. That's pretty... That might actually be one of my worst days, ignoring these two. Oh, man. That sucks. Yeah, so I guess I'll quickly go over the question. The problem gives us some operation to derive like another number from a number that involves like multiplying modulo, divide modulo, and then multiply again modulo. And the first part just says, apply this 2,000 times to each number in the list. What is the sum of the 2,000th number generated by each of the starting numbers? So it's pretty straightforward. You just do it. I had some bugs in that I sort of assumed that, I don't know why. I assumed that we had one secret number and that the secret number referred to our previous one. But when it said like mix and prune, it was referring to the new one. I don't really know why I thought this. Yeah, I don't know why I thought that, but I thought that for a while, and that really confused me, and I got wrong answers. And also, when I did figure it out, I forgot one of the prune steps. I think this one. So that's rough. Yeah, another problem that I had was I didn't really write things in, like writing things in functions actually would have been pretty useful for debugging, and I didn't really do that for the most part. And I felt like I wasted a ton of time just like keyboard manipulation, which was like not very clean. I think some of this is like when my hands are cold because I've just come back from outside. But yeah, really I should maybe invest in a better setup. But I guess that's besides the point. Yeah, so then part 2 says now that this sequence of numbers, if you modulo every number by 10, you get like a sequence that we actually care about. And then if you look at the corresponding differences in every like pairs of numbers here, what it's asking is pick a sequence of four deltas here, such that the sum of the final number, like basically there are monkeys and the monkeys see these price changes and you give them some sequence of 4 price changes to look for, and when they see it, they press the button that wins you this number of points of the final one in the sequence. The final one like at the end of the 4 deltas that they've seen. And the question is like what sequence of 4 deltas is the optimal one that like works best across all monkeys. Yeah, and my initial approach was like kind of silly here. I was like trying to brute force the actual deltas themselves. Like the first one could be anything from -9 to +9. Second one could as well, third one could as well, and so on. Although you probably think that the final one is not going to be like negative, most likely, but I don't know. Anyways, that was what it was asking us to do. And yeah, brute forcing it just does not work well, especially because you're like while that itself is brute forceable in a sense, like you have -9 to +9 is how many numbers is that? 10. That's 19 numbers. 19 times 19 times 19. The last one you can maybe cheese a little bit and only do 9, but like this, either way, this is like really brute forceable. The problem lies in the fact that for each iteration here, the like naive brute force involves going over every single monkey 2,000 times, which is pretty slow. Like just generating the sequences at the beginning was pretty slow itself. So this actually is like extremely not feasible with brute force. But yeah, the approach I ended up going with that worked, and in hindsight is like not that complicated, and I should have thought of sooner, is just like process each monkey one at a time. For the monkey, go through its changes, and every like sequence of 4 changes, you're going to add this number 4 to some score for, like into some dictionary representing like for these 4 things. And if you do this for every monkey, then at the end, whatever the maximum value in this dictionary is like the maximum number of things you can get. because the keys here are like the sequences. So if I actually do what? Scores the items. Yeah, so this is actually the best sequence here. Interesting. You could have guessed that -1, 2, -1, 1. It's a little interesting. Anyways, but yeah, that is how you do it. The one catch is that only the first time the sequence of changes pops up is at the time you win that score. So you need to keep track of like which things you've seen before for a given monkey, and not add to it multiple times. That was another bug that I had, but I figured it out after testing on the sample input. Yeah, it's kind of funny. I figured it out like just by seeing the fact that my sample, like my test, was higher than the sample input. Like this didn't actually unveil anything that meaningful to me. I wonder if there's a lesson to be learned here. Just pretend that my answer is too high and then think about what the possible bugs are. I don't know. Anyways, because like if I could have avoided running the sample input, that could have saved me a moderate amount of time. Maybe not in this question, but when I have to paste it in for other questions, sometimes it does. But yeah, that is all I have for day 22 of Advent of Code. I will see you tomorrow. And probably before tomorrow, I will do day 18 because it is nearing the end of Advent of Code, and I really need to do day 18 before the last day. But yeah, see you tomorrow.